grade 10s, welcome back. Nice to have everybody with us again. Hi Sam, hi Katlego. Please get started on the do now, just while we wait for everybody to arrive. The first question is based on the length of line. Thanks, Sam. The length of a line AB, which is in the diagram, using distance formula. And then the second question is calculating the midpoint, well, the coordinates at the midpoint M. So yeah, question A is based on our first lesson and question B is based on our second lesson. So hopefully that's okay for everybody to try. Hope you've got your calculators and your books and your pens with you. Hi Nizole, hi Adewale, hi Anam, hi Tsebo. Who else is with us? Hi Sihle, hi Nawazi, welcome back. Please get started on the do now. Hi Ria Betswe, welcome back. Nice to have you with us again. Hi Nosisa, welcome back. Please get started on the do now, grade 10s. And when everybody's joined us, then we can get underway with our lesson. Okay, welcome Harry. Who else has just joined us? Just said so welcome. I hope I've said hello to everybody. I don't know if I said hello to you or not. Okay, so please get started on the do now. Sorry if I'm repeating myself. Question A is based on distance formula. That's what we did in our first lesson together. And question B is based on determining the coordinates at the midpoint, which is what we did in our second lesson. All right, so the diagram is there for you. You should hopefully be able to work out the distance and the midpoint M without too much difficulty. I'll just wait for everybody to arrive and then we can mark and get underway. Hi, Jared. Hi, Phoebe. I see you've just joined us as well. Hi, Zayon. Nice to have you with us again. Thank you for joining us. Thanks for the hearts. That's so lovely. Hi, Palesa. Welcome. Hi, David. Welcome. We're just getting started on the do now.
Wait, sorry, ma'am. Ma'am, can you please take this? Can you please scroll down a bit, ma'am? Okay,
Yeah,
well,
sure, Sam, not a problem. Sorry, my girl. Let me
thank
just
you.
make this a little bit bigger. Is that better, Sam? Can you see a bit more now?
Yes, ma'am. Thank you.
Okay, no problem. Sorry about that. If you've managed to do both questions, please can you pop a done or a thumbs up or whatever you want to into the chat so that I know that you're finished. Thank you. Cool, Anna. Cool, Harry. Thank you. Okay, so I don't want to chase anybody, but I obviously want to get underway with our lesson. I know Anam and Harry say that they're done. I'm hoping by now everybody's at least been able to work out the length of AB. Palesa, have you managed to work out the length of AB? Thanks, Nolwazi, so you've done both. Palesa, did you manage to work out the length of AB? Maybe Palesa can't hear me. What about you, Katlejo? Did you manage to work out the length of AB? Thanks, Nolwazi. No, not yet. Okay. All right. Are you struggling with the substituting, Katlejo? Okay, Phoebe. All right. So you didn't manage to do both. All right. I'm sorry that I'm chasing you. It's just I obviously want to get started on. Okay, we'll have a look at it right now. Okay, but we obviously want to get started on the lesson. Okay, Tisetso, you say you're done. Brilliant. Tisetso, what did you get for the length of AB? You can either pop it into the chat or unmute your mic. It's up to you. What did you get as an answer? Six comma 16. Okay, so Tisetso says 6,16. All right, well, I got 2 root 13, which is,
let's work that out.
Okay, that's not 6,16. I get 7,21. Was it you, Sam, that was saying me too?
Yes, ma'am.
Okay, sorry, I was looking at my calculator at the time. Okay, so Tisetsu, I don't know what went wrong there. Who else got 2 root 13 or 7,21? Did anybody else get that answer? Yes, Nuzole, 2 root 13 is perfect. Good, well done. Okay, so that's what I did. All right, so I started off up here and I said -1 minus 3. So that's the first 3, the x at 3, well, the x at b, sorry, which is 3 squared plus then 3 minus -3. Okay, so what I had done in this question is I treated, where's my pen? I had treated at A, I treated that like this was x1, and therefore this was y1. And then here that was x2, and that was y2 and I subbed in. Okay, so hopefully by now you're able to do that. 1 mark for subbing in grade 10s and another mark for the answer. Okay, Rebecca, you've also said that you've got that. Okay, good. I'm glad. All right, Harry, what did you get for the coordinates of the midpoint? Harry says 1 and 0. I agree. That's what I got as well, Harry. Good. Well done. Good job. Okay, so we treated the x coordinate at a minus 1 as x1 plus.
Thank you, ma'am.
You also got that. Cool, Katlejo. I'm so glad. Okay, so minus 1 plus 3 over 2, and then 3 plus negative 3, which is 3 minus 3 over 2 as well. Okay, so again, would be 1 mark for subbing in grade 10s and another mark for your answer. Okay, well, that's good. How's everybody feeling? Is it thumbs up? Coming back to us? We're fine?
A little bit.
Little bit. Okay, it will get better with practice, Katlejo. I promise. Okay, so let's jump in and go and talk about gradient. Let me just move my screen up. Okay, so up till now, we've spoken about distance formula and how we would use it to calculate the length of a line on the Cartesian plane using 2 pairs of coordinates. We've also spoken about how we could use 2 pairs of coordinates and the length, well, a pair of coordinates and another pair of coordinates where one was missing, and the length of the line to calculate a missing coordinate. And we did the same thing with midpoint last week. We used 2 pairs of coordinates to work out the midpoint of a line, and then also knowing what the midpoint was, we worked backwards to one of the endpoints. We can do exactly the same thing with gradient. All right, so first of all, let's just talk about what gradient is and what it means. I've given you the gradient formula there. So it is the change in y, so the difference in y over the difference in x. So we refer to the numerator, you might hear your teachers calling it this, as the change in y. And this is the change vertically. Okay, so this is the vertical change. So i.e., I'll just move the chat box out the way, the vertical change.
Ma'am?
Yes, Katlejo.
So gradient is the letter M.
Gradient is the letter how? Yes. Now, how confusing is that? Because let me just come over here onto the side and then we can come back to gradient now. Okay. So, sorry, these were just extra questions in case we needed them. All right. So, when we're talking about distance, Katlejo, we're going to use a small d. When we talk about midpoint, we use a capital M for midpoint. And then we use a small m for gradient. And the reason that we use a small m goes back to our straight line function. So in other words, y equals mx plus c. So this m over here for gradient is the same m as what's in that formula. Okay, so the gradient of the line. So in other words, how steep the line is. Gradient is a measure of steepness of a line. Let me just go back to where we were over here.
Okay,
and it's
thank you.
Okay, does that make sense? Does that sort of put it into context for you?
Yes, ma'am.
Cool. Okay, just stop me and ask if you've got any questions. And then over here at the bottom, this grade 10s is our change in x. So in other words, our horizontal change. Now, maths teachers are very strict. If you are subbing into the gradient formula and you put the change in x at the top and the change in y at the bottom, you won't get any marks for subbing in. So you've got to be really, really careful, grade 10s, when you sub into gradient formula. Make sure that you're putting the y coordinates at the top and the x coordinates down at the bottom, okay? Otherwise, you're not going to get any method marks for subbing in. So when we talk about gradient, we are talking about the slope or the steepness of a line, okay? So of any line that joins 2 points together. So in the figure below here, we have got line OQ, and it is the least steep out of all of them, okay? So if you can imagine that you're standing at O and someone asked you to walk to Q, all right, you'd be much happier if somebody said to you, stand at O and walk to Q, than if somebody said to you, stand at O and walk to T. Can you see how much steeper it is? Nzole, very good question, all right? So QT is the steepest. I'm going to show you something now, Nzole, all right? Look here. Let's say I've got a pair of coordinates. Here my coordinate is 1 and 3, and here my coordinates are -2 and -5. Nzole, if you decide that this coordinate over here is going to be y number 1, that's okay, as long as its corresponding x is x1, which means this has to be y2 and this has to be x2. So if you come along and you go 3 minus -5 over 1 minus -2, you will get exactly the same answer than if you do this. So now I'm going to get rid of the 1 there, and I'm going to get rid of the 1 there. I'm going to get rid of the 2 there, and I'm going to get rid of the 2 there. Now look what I'm going to do. Use a different color. Now I want to make this one this needed to be y2. Then that means this must be x2, which means this must be y1, which means that must be x1. So now I'm going to do this, Nzole. I'm going to start with -5, and now I need to subtract 3. Then I'm going to start again over here with -2, and I need to subtract 1. Now let me compare my answers. 3 minus -5 is going to leave me with what at the top, Nzole? What am I going to have in my numerator? -2, +8. When you subtract a negative, you're going to be adding. Does that make sense to you? So 3 minus -5 becomes 3 minus -5, yeah, becomes 3 plus 5, which would be 8. So I'm going to get 8 at the top. Same thing at the bottom. 1 minus -2 is going to become 1 plus 2, so I'm going to get 3 at the bottom. Look what happens in this question over here, all right, when I swap them around. I'm now starting with -5, and I'm taking away 3. I end up with -8. I'm starting with -2, and I'm taking away 1. I get -3. A negative divided by a negative is a positive. So, Nzole, to answer your question, it does not matter where you start. If you make -5 y2, -2 has to be x2. And that means that 3 has to be y1 and 1 has to be x1. But if you do it the other way around and you make 3 y2, then you've got to make its corresponding x, x2 as well. All right, so if you start with 3 at the top, you've got to start with 1 at the bottom. If you start with -5 at the top, you've got to start with -2 at the bottom. Does that make sense to you? And as long as you do that, you'll end up with the right answer. Does that answer your question, Nzole? It's a common thing that's asked by grade 10s. Does that make sense? Cool beans. Okay, so gradient is a measure of how steep a line is. So line OQ is the least steep and line OT is the most steep. So as your gradient increases, so its value increases. So in other words, if I was to work out the gradient of OQ, it would be a smaller value than the gradient of OT. Okay, until eventually your gradient can be 0. Does anybody actually know what happens when gradient is 0? What happens to a line if I make its gradient 0? Does anyone know? Were you going to say vertical to set so? You don't know. That's fine. Okay. So you're almost on the right track to set so. You've just got two things muddled up. Okay. When if I do this with a line, so in other words, if I come down, all right, the gradient is decreasing. Until if I had a point at O, and I now drew a straight line, and let's say I decided to call that K. The gradient of OK is going to be 0. Why will it have a 0 gradient, do you think? If you were standing at O and you had to walk to K, would you be walking uphill?
And you'll be walking straight, I guess.
You'd be walking straight, isn't it? So you wouldn't be walking uphill and you wouldn't be walking downhill. You would be walking along a flat surface. So when we are walking along a flat surface, we say that there is no gradient. Gradient is 0. Does that make sense? Okay, so if I now draw another line down there, and now I say to you, okay, grade 10s, now you want to walk from O to P. Are you walking uphill? You're not, are you? You're now walking downhill. Okay, you're walking down from O to P. So that is why any gradient that increases from left to right, like these ones over here, OT, OS, OR, those are all positive gradients. OP has a negative gradient. So any line that is a horizontal line will have a negative gradient. Okay, so if I draw a horizontal line like that, okay, this would be called the line y equals 4. Does that make sense to you, grade 10s? Do you know that horizontal lines are named as y equals and that vertical lines are named as x equals?
Ma'am, is it an asymptote?
It can, yes, Sam. So absolutely. So often these lines are asymptotes. So sometimes we have vertical asymptotes, sometimes we have horizontal asymptotes. But yes, an exponential function has a horizontal asymptote. So does a hyperbola. Okay, but anyway, sorry, we're talking about gradient in this particular case. So here the gradient would be 0. This line over here, the gradient would be 0. I don't know what the gradient of OQ is, but let's say the gradient of OQ is a half, then this could be 1, that could be 2, that could be 3. It's getting steeper. But now when I come down here to OP, I'm walking downhill. So now my gradient could be something like -2 or -3. Okay, so Nzole, it measures gradient. It measures how steep the line is. So again, place yourself, Nzole, at the origin. Now imagine I say to you, walk from O to Q. All right, it's not that steep. You're not going to mind. But if I say to you, Nzole, walk from O to T, you're going to be exhausted by the time you get there, aren't you? Because you're literally climbing a steep, steep, steep hill. Okay, so that's what gradient does. Gradient is a measure of how steep the line is. Okay, and that can either be 0 in the case of a horizontal line, or it can be positive, or it can be negative. Okay, and that's what I wanted us to talk about now. Okay, so gradient can be positive or negative. I've got a little graph here to show you what a positive gradient would look like. That's the pink one. So if you can imagine, okay, David, if you are standing down here, okay, and I say to you, David, you've got to walk all the way to here. Are you walking uphill or downhill, David?
Ma'am, come again. I don't understand the question.
So if you're standing over here, this is you with a big smile on your face over here. And now I want you to walk over here. Are you walking up the hill or are you walking down the hill?
Up the hill.
Up the hill. So you are walking uphill. Are you happy about walking uphill? Are you? Okay, that's good. Okay, so here you are walking uphill. So what that means, David and the other grade 10s as well, is that here the gradient is positive because you are going plus y, you're going up, and you're going plus x. So in other words, you're going up and to the right, and up and to the right, and up and to the right, and up and to the right. Okay, so when we go up and to the right, up is a positive y value, to the right is a positive x value. So that's why gradient is positive, because that's why the gradient would be positive when we go up and to the right, because a positive divided by a positive would give us a positive. On the other hand, okay, now imagine that you are standing over here. And now you need to walk in that direction down this hill until you get here. Are you still walking up?
No.
You're not, are you? No, you're not. Because now you're walking down and to the right, and 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 so onwards. So when you walk downhill, all right, that means the gradient is negative. Exactly, because y is negative, even though we're moving in a positive direction in terms of x. Okay, so we're moving down and to the right. So a negative divided by a positive gives us a negative overall. A positive divided by a positive gives us a positive overall. So that's why here your gradient is positive, and here your gradient would be negative. Does that make sense to everybody?
Yes, ma'am.
So, ma'am, can you change the signs on the formula?
You don't need to put the sign on the formula, because when you calculate the value of the gradient, it will either come out as a positive or as a negative, depending on the coordinates that you have substituted in there. So I'm going to show you that now, Katlego, when we sub in. So hang on a second. Here we go. Calculating the gradient of a line segment. All right. So we're going to use gradient formula to be able to do that. Again, we come along and we need to label our coordinates. So if we decide that this is going to be x1 and that's going to be y1, this has to be x2 and 9 has to be y2. So now when we calculate the gradient of our line, we're going to put in the 9 first. So 9 is going to go in the place of y2. Let me just get the formula down. 9 is going to go in the place of y2 minus 5 goes in the place of y1 minus 3 and then minus 2. So here, what am I going to end up with on top? Katlego, 9 minus 5 is going to leave me with? Watch in the numerator.
Ma'am, can you repeat your question?
Sure, with pleasure. I'm just asking you to work out the value of the numerator for me, please, Katlego. So 9 minus...
Cool.
Yes, good. Well done. And what am I going to get in the denominator, Katlego?
-5.
Indeed. Okay, so now can you see this gradient is a negative gradient? So in other words, if you were standing at E and you needed to walk to F, you would be walking downhill. You wouldn't be walking uphill. Does that make sense? Right. So the other thing that's really important, let's just talk about this quickly before I give you an opportunity to try one. This is actually a really good example. If I write 4 over negative 5, or I write negative 4 over 5, or I put the negative in front and then I put 4 over 5 like that, is there any difference between any of these fractions?
No, ma'am.
No, they're all the same. They're
Yes, ma'am.
all the same. All the same. Okay, so it does not matter where I put the negative. Here, I'm saying, so I'm just saying, Katlego, it doesn't matter where I put the negative in my fraction. If I put my negative at the denominator, like it is in the first one, or if I put my negative in the numerator, like I have with the second one, or if I put my negative at the front, it doesn't matter. It all means the same thing. So either which way it comes out, right? Doesn't matter how you write it. But here, what you would say is that the gradient is negative. So essentially what is happening here, all right, is that for every 4 units that we walk down, we are also walking 5 units to the right. That's what it means. Okay, so for every 4 units we walk down, we're walking 5 units to the right. Okay, remember the number at the top is the change in the y, the change in the vertical. Okay, the number at the bottom is the change in the horizontal. Okay, so because this gradient is negative, it means we're walking down and right and down and right and down and right. Down 4, right 5, down 4, right 5. Does that make sense? Okay, your turn. I'm going to give you 4 minutes and let's see if you can work out the pink, and if you finish with the pink you can try and do the blue as well. If you are finished, you can pop a done or a thumbs up or something like that into the chat for me, please. Cool, Harry, well done. Both of them. Cool, David, well done. Nice, good job, Harry. Well done, NM. Well done, Sam. Cool, David. Good job. Okay, so that is our 4 minutes up. Hopefully everybody's been able to do at least the pink one. Shame you guys are quiet today. Has it been a long day at school? Are you looking forward to breaking up? Is everybody feeling tired? Is that why you're a bit quiet? Tired and ready for a holiday. Okay, all right. So let's see what results you got. Okay, so Sam, what did you get for the pink one?
Ma'am, I got 9/11.
There we go. I got 9/11 too. Okay, good job. Okay, so, okay, tired is an understatement. I understand, Tutuka. I can well imagine this has been a hectic term. All right, we're nearly there. We've just got to get through the next couple of weeks. Tutuka, did you manage to do the blue one? If you did, you did. And if you didn't, that's also okay. Okay. Phoebe, you're also very quiet tonight. What did you get for the blue one, Phoebe? You didn't get to it. Okay, Phoebe, that's fine. Okay, Nasisa, you get 11/8. Cool beans. Let's see. Ha, well done. Yes, well done, Anna. Well done, Nasisa. Perfect. Good job. Well done, Harry. I understand, Phoebe. Oh, good, Nzole. Well done. I'm glad you got that too. Okay, so that was fairly straightforward. Don't worry, guys. The holidays are just around the corner. You just got to hang in there. All right, we're nearly there. We're nearly there. Okay, so now that we've practiced substituting into gradient formula, now I want to show you how we would work backwards, okay? So in this particular case, we have been given the gradient of line CD, and we've been told that its gradient is 2/3. They want us to work out the missing coordinate P, which is the missing Y coordinate at D using gradient formula. Okay, so now what I'm going to do is use my gradient formula. I'm going to write it down. And what am I going to write in place of M?
2/3.
2/3. Good, Katlejo. So in place of M, I'm going to write 2/3. Now, if I come along and I say, okay, that's X1, that's Y1, this is X2, this is Y2. Okay, so that means that in place of Y2, I'm going to write P minus Y1 minus 2 over, what am I going to put at the bottom? Let me ask Zayon. What am I going to put at the bottom, Zayon? What should I write? Maybe Zayon can't hear me. Oh, you did. Okay, Anam says 8 minus 16. Good. Good, Zayon. Yes, perfect. Sorry, I didn't give you an opportunity to respond. Yes, you're both right, 100%. So 8 minus 16 at the bottom. Good. Well done, grade 10s. That's excellent. Now, oh, is your connection going on and off? Okay, I don't know if you want to maybe try logging off and then logging back on, Zayon. Maybe that will help. Sorry about that. Okay, so now, very important, grade 10s, brackets around binomials. Okay, so that we don't forget to multiply both terms in the numerator by what's in the denominator. Here, 8 minus 16, again, we can just put a bracket around it, but it really doesn't matter. I need to do what now, grade 10s? What method am I going to use in order to be able to solve for P? It's something that we've spoken about often together.
Ma'am, isn't it cross multiply?
It is indeed, Sam.
Cross multiply.
Cross multiplying, David. Yes, lovely. Well done. I'm so pleased that you guys said that. That's great. So now I'm going to cross multiply. So 8 minus 16 is negative 8, right? And negative 8 times 2 will leave me with negative 16. Is everybody happy where that came from? So I've said 8 minus 16 is negative 8, and I've cross multiplied negative 8 with 2 to get negative 16. And I'm going to do the same thing on the other side. I need to say 3 times P will give me 3P, and 3 times negative 2 will leave me with negative 6. Does that make sense? Grade 10s, I have cross multiplied.
No, ma'am.
It doesn't. Okay, I can do it again. Just quickly here on the side. Okay, so I've got 2 over 3 equals P minus 2 over 8 minus 16. So, Katlego, I've left the 2 over 3 as 2 over 3. I can't do anything to P minus 2 because they're not like terms. And I'm saying 8 minus 16, which leaves me with negative 8. Does that make sense?
Yes, ma'am.
Happy with it? Okay. Now I'm going to cross multiply. I'm going to multiply negative 8 and 2 together. So negative 8 times 2 is negative 16.
Negative 16.
Good, yes. And now, Katlego, I have to multiply 3 with P, but it's not just with P and negative 2. It's got to be P minus 2. So now I'm just doing distribution. So in other words, what I'm doing is this. 3 times P minus 2. Okay, so that means that I'm going to end up with, you can, Harry, you can multiply both sides with negative 8. But the thing is, with cross multiplying, what you're doing, or the beauty of this, Harry, is that when you cross multiply, you're multiplying both sides by negative 8 and both sides by 3 at the same time. So it saves you time, because you're going to have to do that anyway, aren't you? You're going to have to multiply both sides with negative 8 and with 3. So it just saves you time when you cross multiply. I think it's very clever. Okay, so then expanding our brackets, Katlego. Hopefully now you can understand 3 times P gives us the 3P, and 3 times minus 2 is where the minus 6 came from. All right, so now we need to solve for P. So that means that this minus 6 has to go over to the other side. So it's going to become minus 16 plus 6. So that means that minus 16 plus 6 will leave me with negative 10. Whoopsie. Negative 10. And I've got 3P over here. And now what am I going to do, grade 10s? I've got to divide both sides by
3.
I've got to divide both sides by 3. Okay, so that means that it's a bit of an odd number, but anyway, this can happen. We can have a coordinate like this. Our coordinate at P, our second y coordinate, is the value minus 10 over 3. Is that okay, grade 10s? Is that making sense? Cool, David. Anybody got any questions?
Ma'am, can you take the screen up a little bit?
Of course I can. Hang on one moment. How's that? Is that better? Sorry, because I sort of ended up writing on the left and then writing on the right-hand side as well. Okay, down a little bit. Okay, so
yeah,
just
so I
while
can see. The sum.
Can you see it? What do you want me to do? Sorry, Katlego?
I want to see the sum, ma'am. Also the calculations.
Oh, there we go. So you want to see the sum and the calculation.
Oh, thank you, ma'am.
Okay, all right, that's fine. So I'm just going to leave it there for 2 seconds. All right. Everybody, I want you to have a turn as well. Okay, so it's a very similar question. If the gradient of CD is 2/3, find P. Okay, so what I'm going to do is I'm just going to move this out from behind here and I'm going to pop it over there. Okay, now I didn't notice this until now. Please just ignore the P over there. Okay, so here are your coordinates. C is 3 and P. D is 9 and 14. The gradient of CD is 2/3. Just like I've done it now, please can you find the coordinate at P? Okay, so I'm going to give you 5 minutes to try that. If you've got any questions, please ask me. Everybody okay, grade 10s? Thanks, Nasisa. All right, give that a try. And even if you get it wrong, it doesn't matter. We'll fix it. Okay, just give it a try. Oh my word, Harry, you done already? Oh, wow. You are Speedy Gonzalez, aren't you? Oh, well done, Maya. You also finished. Excellent. Good job. That was very good. What's the number next to 3? That's a P. It's a P. So at C, the coordinates are 3 and P. So here, P represents the Y coordinate at C. Katlego, is it okay if I move the screen up again? Have you managed to get that down? Done. Well done, Anam. Good job. Okay, so I'm going to move that up now. Oh, I did include the 2. Okay, well, anyway, it doesn't matter. Okay, so Anna, what did you get as an answer for P? Anam says 10. Okay. Harry also got 10. And Nasisa got 10 as well. Okay, well, I'm thinking that if I know I changed the question at the last minute, but if you guys all got 10, then 10 was the right answer. Yes.
And I got negative 10.
You got negative 10, negative 10, Sam, sorry. Sam says P is equal to negative 10. What am I writing here? Okay, all right. Everybody's saying 10, 10, 10. Okay, let's quickly do it and see what happens. All right, so 2 over 3, the gradient, is equal to, if I say P minus 14 at the top, then I've got to say 3 minus 9 at the bottom. So that gives me 2 over 3 is equal to P minus 14 at the top, and 3 minus will leave me with negative 6. So negative 6 times 2 is negative 12, and 3 times P is 3P, and 3 times 14 is going to leave me with 42. Is that right? What's with no?
It's 42, ma'am.
Yeah, it is 42. I was right. Okay, it would leave me with negative 42. Okay, so now I want to move the negative 42 over to this side. So now I've got negative 12 plus 42 is equal to P. Let's just move this down. You guys are right. It is going to be 10. Okay, so now we've got, so don't know what happened there. Sam, have you been able to find your mistake?
Now I don't understand, because then the formula says y2, and y2 is 14. So 14 was supposed to be the first one before P, right? Instead of P minus 14.
Okay, Sam, it shouldn't matter which way around you do it. I'll do it the other way around for you as well. Let's do it your way, and then we will end up with the same answer. Okay, so as long as you start, if you start at y2, you must start at x2 at the bottom. If you start at y1 at the top, you've got to start at y1 down at the bottom. So let's do it your way around, okay, Sam? Okay, so we're still going to have 2 over 3, right? But except at the top, we're going to have 14 minus P. Let me just check that my signs are correct. Is that right? 14 minus P, which means at the bottom, I have to have 9 minus 3, don't I?
Yes, ma'am.
Okay, so now I've got 2 over 3 equals 14 minus P over 6. Is that correct? 9 minus 3 is 6. And now I'm going to cross multiply, Sam. I'm going to multiply 6 and 2, and I'm going to get 12. And then I'm going to multiply 3 with 14, and I'm going to get 42. Yes, we're going to do another one. We're going to do the exit ticket, okay, Kakeho? And then 3 times negative P is negative 3P. So now what I'm going to do, Sam, is I'm going to take this negative 3P over to this side.
Oh,
and it's going to become positive 3P.
I took the 42 on the other side. I think that's what made it wrong.
Then what you should have got, if you had 12 minus 42, then you should have got negative 30. And then if you divided both sides by negative 3, then you would have got P is equal to 10. Does that make sense?
Yes, ma'am.
Okay, so 3P is equal to 30, which means that P is equal to 10. Well done, grade 10s. 10 is obviously a good number for us, isn't it? Lovely, well done. Okay, so here we go. We've got time for our exit tickets. So let me just make that a little bit smaller. What was I doing here? Okay, actually, I don't know. Is that big enough? Can you guys see that okay? All right, so I've given you a sort of greeny one and a blue colored one. All right, in the question on the left, you're going to calculate the gradient of the line. And in the one on the right, ooh, see, I'm showing you my answers here. Let me just move that. Ooh. Move that out the way. We can grab it now. Okay, there we go. Give it a whirl. Okay, so the one on the left is calculating the gradient of the line. The one on the right is calculating the missing y coordinate Let's see what you guys do. Ready, steady, go. Okay, so Katlego, you wanted to do the one on the left together. Write down your gradient formula. And then I want you to label your coordinates at A and B. X1, Y1, X2, Y2. Oh, wow. Well done, Katlego. Okay, try the one. Have you done both of them?
Yes, ma'am.
Okay, brilliant. So you've worked out the gradient of the one on the left and you've worked out the missing y coordinate of the one on the right. Is that right? Well done. Okay, Harry, good job. Okay, no problem, Katlego. Okay, so now that you've written down your formula and you've labeled them, substitute. Okay, put what you've labeled as y2 in place of y2 and put what you've labeled as y1 in place of y1 and do the same thing with your x coordinates. It wasn't very nice of me here. Oh, sorry, I didn't give you the formula. Sorry, grade 10s, but I mean, you have probably written it down in front of you. Beg your pardon. Sorry. These formulae will always be given to you. But obviously, if we learn them off by heart, it means that we can just work easier and quicker, which is what we always want in maths. Okay, so please pop a done into the chat when you've finished. Unfortunately, we're getting to the end here and we need to finish off now. Our time together always goes so quickly. Well done, Maya. Well done, Anna. Good job. Well done, Tisetso. Well done, Sam. Good job. Finally done. Okay, Zayon, good job. Well done for hanging in there. Okay, so we've only got 2 minutes to go. So I'm going to show you my answers and hopefully you guys, well, actually, instead of me showing you my answers, Zayon, what did you get for the one on the left? The gradient of line AB. What did you get, Zayon? You got, okay, Harry said he got -1/2. You got 4, is that 4.5, Zayon? -1/2? Oh, where's my calculation gone? Okay, that's what I got. I got minus, what is that? I got minus 3/8. Oopsie. I don't know.
Ma'am, I got negative 1/2.
Maybe I'm going crazy. Okay, hang on a second. Okay, you're all getting negative 1/2. How did I get that? Sorry, grade 10s. You must think I'm absolutely nutty. All right, so if we call this one, sorry, x1, y1, x2, y2. Okay, so now we're going to sub into the gradient of line AB, and we're going to say 0,5, that's y2, minus 2 over 2 minus -1. So a half minus 2 is going to be -1.5, and 2 minus -1 is going to leave me with 3, and I obviously can't leave my answer like that. So if I have got 5 and I've divided that by 3, sorry, you are all perfectly correct, and I am obviously completely nutty. Well done, grade 10s. Excellent. Okay, -1/2 is the right answer. Good job. Well done, everybody. Don't know what I was doing there, but my apologies. Okay, well done that you got that right. Okay, and then let's do the last one over here. The missing coordinate at B. What did you guys get? Pop it into the chat. Okay, so Nozole says y is equal to 4. Sam says 4. Harry says 4. There we go. All right, so I'm not completely nutty, grade 10s. I also got 4 as an answer. Okay, you also got 4, Zayan. Well done, Gisetso. I'm glad we all got the same answer there. Good job, grade 10s. Well done. That's really great. So we've made a lot of progress so far. We've walked forwards and backwards with all 3 formulae. So hopefully you are feeling confident with being able to do that. And then we can go and see how we apply these to the different kinds of questions that come our way and the lessons that follow. Well done, everybody. Big hand of applause to you. Great job. I'm going to hand you back over to Tula now.
Hi, grade 10s. How you guys doing? I just want to check in. I know earlier Phoebe already mentioned, Phoebe and Tutuga, that they're very tired and it's been a long week. How you guys doing? It's the end of term. I know for you, some of you are done with exams. Some of you are finishing this week. How you all feeling? Just let me just get some thumbs up. You can unmute your mic if you feel like speaking. If you're watching from the live stream, also indicate with a thumbs up or thumbs down how you're feeling. Zayan says they're feeling exhausted.
Exhausted. Sorry, Zayan. Understandable.
Yeah, it's probably grade 10 is very tough, and you guys are now nearing the end, and so it's understandable that you all, maybe most of you, are feeling exhausted, but just keep pushing. You know, all this time that you're spending doing extra lessons, it's all going to pay off. It's all going to mean something when you're actually sitting down and writing your papers. So I absolutely get how you're all feeling. David and Adewale says, oh, David is starting on Thursday, the test, and Adewale is starting next week. Okay, I thought a lot of you guys were actually done. Katlejo says, I didn't write anything on my maths paper yesterday. For some reason, I didn't know anything. Oh, Katlejo, that's very sad. But
Katlejo, sorry.
Yeah, that's very sad. I'm so sorry for that. But I mean, it's why you're here now on these extra lessons. You know, you're putting the extra effort, and more often than not, the extra effort usually does result in better results. So just keep pushing. It's very far from over. So let's keep pushing. You guys can keep sharing your answers. I'm very interested in seeing them. In the meantime, I'm going to quickly share my screen. just so I show you guys the lessons that we still have to go. We've pushed so much, and with analytical geometry, we only have 3 lessons to go. So today we just finished our lesson 3 doing gradient formula, and we have lessons 4, 5, and 6 remaining. So just make sure that you're consistent and you keep attending that, so that your analytical geometry knowledge is just well-rounded and full. You know, you don't want to have gaps. And of course, keep doing the quizzes in between, and keep doing on the app, watching the lessons. Just on your side, do what you can. You know, just, you have a lot of resources that we're making available to you. Make sure that you use them. If you're tired, rest, and then get up and get back to it. Yeah, but you guys are doing that so far, so we're very proud of you. And of course, remember, as always, remind you guys that if you find these classes helpful, chances are there's someone in your class or in your circle that also finds them useful. So make sure that you share the link that we did send to you guys on WhatsApp with a friend or someone else that you know might need these classes. Even if they're doing well in maths, maybe they might want to get more practice material and things like that. So please make sure that you do that. You know, sharing is caring, so you can help someone else. And before I let you go, remember that your homework you have homework, and your homework for this week, we want you guys to go to the app, click on analytical geometry, and then scroll down to gradient, and then go to using the gradient formula. And then you can just watch the lessons there, do any quizzes that are available just to test your knowledge. It only helps you make sure that you understand the lesson. But that's it for this evening. Enjoy the rest of your evening, guys. Enjoy. We'll see you on Thursday, and hopefully we'll find out how your tests went. Yeah, I'm sure it must be stressful, Sihle, but remember to just breathe, do all you can from your side, and you can't do more than that anyway. You can't do more than your best. So just do that, and then try to relax as much as you can. Bye, everyone. Enjoy your evening.
Bye, everybody. Well done. See you on Thursday.